graphing polar equations. So there's different types of things or graphs that we could get when we're given a polar equation. The first one is called a Rose curve, and for Rose curves, r equals the a value times the sine of n times theta, or r could equal a times the cosine of n times theta. The variable a represents the petal length. If n is odd, there are n number of petals. If n is even, then there are 2 times n number of petals. Also, we can figure out symmetry. So if the equation contains sine, the graph is symmetric with respect to the y-axis. Because remember, sine goes along with the y values. And if the equation contains cosine, then the graph is symmetric with respect to the x-axis, because cosine goes with the x. To obtain the important points for the graph, the scale of your theta values for your table should go by pi divided by 2n. So this is something we have to learn by heart. And just know, if we have a Rose curve, so if it's just a times the sine of n times theta or a times the cosine of n times theta, we're going to get what's called a Rose curve, and it looks like a flower with different petals. And to scale our table, we are always going to take pi and divide it by 2 times the n value. So in our first example here, r equals 2 times the cosine of 3 theta. So first of all, because a is 2, the petals are going to be 2 units long. The n value here is 3. Because that's odd, there are going to be 3 petals to our graph when we're done. And because it has cosine, we're going to have x-axis symmetry. All right, so now I'm going to take pi and divide it by 2 times n. So since n is 3, I do pi divided by 2 times 3, and so I'm going to get pi 6. So I'm going to start always at 0, and then I'm going to count up by whatever I got when I did pi divided by 2 times n. In this case, that's pi 6. So 0, pi 6, 2 pi 6, which is really pi thirds. 3 pi 6, which reduces to pi over 2, 4 pi over 6, which would reduce to 2 pi over 3, 5 pi over 6, and 6 pi over 6, which reduces to just pi. Okay, so we're going to take each one of these values one at a time, plug them in to our equation given to us here, and figure out what r would equal. So if theta is 0, we have 2 times the cosine of 3 times 0, which would just be 2 times the cosine of 0. And we know the cosine of 0 is 1, so 2 times 1 gives us 2 as our first r value. If we plug in pi 6, well, 3 times pi 6, 3 is 3 over 1, so we would get 3 pi over 6. But that really just reduces to pi over 2. Oops, forgot my cosine. And we know the cosine at pi over 2 is 0, so this is just 0. If we plug in pi thirds, so 2 times the cosine of 3 times pi thirds. Again, 3 is 3 over 1, so we would end up with the cosine of 3 pi over 3, which really just equals the cosine of pi. And we know that the cosine of pi is -1, so 2 times -1 gives us -2 for our r value there. All right, so next one, pi over 2, so 2 times the cosine of 3 over 1 times pi over 2. So So we get 2 times the cosine of 3 pi over 2. We know that the cosine down at 3 pi over 2 is 0. So 2 times 0 gives us 0. Next one, 2 times the cosine of 3 over 1 times 2 pi over 3. So we would end up with the cosine of 6 pi over 3, but that's really just 2 pi. Which is the same as 0, and we know there the cosine is 1. So 2 times 1 gives us 2. If we plug in 5 pi over 6, so again 3 over 1 times 5 pi over 6, we'd have 2 times the cosine of 15 pi over 6. 15 pi over 6, both 15 and 6 are divisible by 3, so it really reduces to 5 pi over 2, which 5 pi over 2 we know would end up back at pi over 2, and there the cosine is 0. So 2 times 0 equals 0. All right, so this last one, so 2 times the cosine of 3 times pi equals 2 times the cosine of 3 pi, and we know that 3 pi is really the same as just pi if we subtract 2 pi. And so there the cosine is -1, so 2 times -1 gives us -2. So we see the pattern to this. R was 2, then it was 0, then it was -2, then 0, then 2, then 0, then -2. All right, so our first point we'll plot when theta is 0, the radius is 2, so we're right here. When we're at pi 6, we're back at 0. At pi thirds, we are at -2. So here's pi thirds, but -2 sends me over here to 4 pi over 3. So I gotta go to -2 over here. And then at pi over 2, we're back at 0. 2 pi over 3, we're out at 2. And then 5 pi over 6, we're back at the 0. And at pi, we're at -2, which would send us back to this point here that we already have. Because here, but then since it's -2, we send it this way, so it ends up right there. So let's draw in our petals. So remember, at pi 6, we have to be back at 0. So here, at pi halves, we're back at 0. And at 5 pi over 6, we were back at 0. Oops, made that one a little too wide there. So by that line, we gotta have made it back to 0. Then at pi over 2, 5 pi over 6, and so we just keep going with this pattern. Oops. And by 7 pi over 6, we'd be back at 0, and by 3 pi over 2, we'd be back at 0. By 11 pi over 6, we'd be back at 0. So here is our first rose curve. Pretty little flower there with 3 petals to it. All right, so let's take a look at one with y-axis symmetry. So example 2 here, r equals 3 times the sine of 2 theta. So again, the a value is 3, so that's our petal length this time. It's going out to 3. N is 2, so that means there's going to be 4 petals, because remember, with an n value that's even, we got to double it. So 2 times 2 gives me 4 petals for our graph. Because it's sine, this is going to have y-axis symmetry. So again, we always start at 0, and we're always taking pi divided by 2 times n, which in this case was 2. So pi fourths is what we're going to count by this time. So 0, pi fourths, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, which reduces to just pi, 5 pi over 4, and 6 pi over 4, which reduces to 3 pi over 2. And that should be enough to get us the pattern to understand what's going on to sketch in this graph. So one at a time, we'll take them and plug them in, see what we get. So 3 times the sine of 2 times 0 means we have 3 times the sine of 0. And we know the sine of 0 is 0. So 3 times 0 just gives us 0 for the first one. So we start at 0, 0. If we plug in pi fourths, so remember 2 is 2 over 1, so we multiply it by pi fourths, we get 2 pi over 4, which reduces to pi over 2. And we know the sine of pi over 2 is 1, so 3 times 1 gives us 3. So this time we're plugging in pi over 2. So again, 2 is 2 over 1 times pi over 2 gives us 2 pi over 2, or just pi. And we know the sine at pi is 0, so 3 times 0 gives us 0. If we plug in 3 pi over 4, so 2 times 3 pi over 4 would be 6 pi over 4, but that'll reduce to 3 pi over 2. And we know that the sign down at 3 pi over 2 is negative 1. So 3 times negative 1 gives us negative 3. If we went 0, 3, 0, negative 3, I bet this next one's 0. Let's see it. So 3 times the sine of 2 times pi. So we're going to have 3 times the sine of 2 pi. And we know the sine at 2 pi is 0. 3 times 0 just gives us 0. All right, so if we have 5 pi over 4, so again, 2 is 2 over 1, times the 5 pi over 4, we get 10 pi over 4, which would reduce to 5 pi over 2. And so 5 pi over 2, if we subtract 2 pi, which would be 4 pi over 2, is the same as just pi over 2. And we know that the sign there is 1, so this is 3 times 1, so we get positive 3 again. So bet you we get 0 here. So 3 times the sine of, I forgot my 2. 2, which is 2 over 1, times 3 pi over 2. So we would get the sine of 6 pi over 2, which is really just 3 pi. And if we subtract 2 pi from that, we would get just pi. And we know the sine of pi is 0, so 3 times 0 gives us 0. And if we would do the next one, so let's just do it so we can see it. So if we do 7 pi over 4, we're going to be back at negative 3. Because 2 over 1 times 7 pi over 4, we would get the sine of 14 pi over 4, which reduces to 7 pi over 2. But that's the same, if I subtract 4 pi over 2, that's the same as 3 pi over 2. And we know the sign there is negative 1. So we'd be back at the negative 3. So we can see the pattern, 0 to 3 to 0 to negative 3 to 0 to 3 to 0 to negative 3 to 0 to 3, and so on. So we start at 0, 0. At pi fourths, remember this is pi fourths, so at pi fourths we are out at 3, so we're here. And then we're back at 0 at 3 pi over 4. So over here would be 3 pi over 4. We're at negative 3. So rather than here, we got to send ourselves, add pi to it, be over here at 7 pi over 4. Or just send yourself through the origin to the other side. So we'd be there. Then we're back at 0 at 5 pi over 4, which is here. We are at 3. So 1, 2, 3. Then we're back at 0, and again at 7 pi over 4 we'll be at -3, so it's going to send it out to here. And so we just got to make sure we're back at 0 in the right amount of time. So like we're back at 0 by pi over 2. So I know like how wide to make n by 0 each of my petals, and by pi, so coming from 0 and by pi I got to be back at 0 and here, and by 3 pi over 2. So there's my pretty flower with 4 petals this time. So it had y-axis symmetry, so if we would fold it along here, everything's going to match up. Whereas this one, for it to be symmetrical, we have to cut it with the x-axis. If we fold it over the x-axis, everything would line up. And again, that's determined by whether it has cosine or sine in it. So those, again, are called rose curves. They just have the a times the sine of n times theta, or a times the cosine of n times theta.